The final thing I want to talk about is why do we actually care about capacitors? What do they do for us? Well, I want you to think about setting up a capacitor in a circuit. This time I'm going to add a switch. Okay, this is the symbol for a switch. Okay, when I close the switch, I'll end up putting charges on the capacitor plates. Okay? Then I can go ahead and open the switch, and the charges stay put. Well, the charges staying put means something very interesting. What it means is that I could let the charges jump across this gap here, or I could put a wire between here, okay, and let the charges flow across. And if they did, the positive charges would gladly move to the negative side, or vice versa, okay? And in moving, they'd pick up energy, which means there's energy stored on those plates, okay? Now, we can work out how much energy it has to be based upon the electric field and the charges, and use the fact that the PE we found in class last week was QED. We can work it all out. It turns out, though, I'm not going to do it, because to do it properly, you need calculus. At some point, you've got to basically add in the fact that the electric field keeps decreasing as charges move off the plates. And I don't want to do that. So we're just going to go ahead and jump to the conclusion, which is that energy is equal to 1/2 CV squared. Okay? 1/2 the capacitance times whatever voltage was applied across it squared. Now there's other ways to write this. Since CV equals Q, we can go ahead and get rid of the V here if we want to. Still got the 1/2, but now we got V is equal to Q over C. So this becomes Q squared over C squared times C. That's Q squared over C. Okay? And there's also a third way of writing this, of course, which is to get rid of the C completely. Okay? C is equal to Q over V, so this is 1/2 QV. Okay? All of these mean the same thing. Okay? But what does that actually mean for us? What this means is capacitors store energy. So far, we haven't really met a way of storing electrical energy, per se. We have these magic batteries that we haven't talked about with doing things in our circuits. And they're wonderful, actually, and we think of them as storing energy, and in a way they do. Capacitors also store electrical energy, but they store it as electrical energy specifically. Why is that advantageous? Well, there's a lot of things capacitors can do for us. The main thing capacitors are really awesome for energy, it turns out, is that they release their energy very, very quickly. If I were to short circuit this, put a wire across here when the charges were on here, charges would flow very, very quickly from the positive to the negative, okay, around that way. A battery takes a while to get current going and doesn't really push the energy out of itself quickly. That's one of the things you like about a chemical battery, actually, is that it doesn't discharge completely right away. A capacitor will try to discharge as fast as it can, which can be very quickly. Why is that good? Well, there's a number of applications where that's useful. Flashes on cameras often use capacitors so they can store up energy while you're waiting in between shots. And then when you take your picture, they release all of the energy all at once as one burst of light. Okay? Fantastically useful. Another good use of them is, for instance, in a backup system. If you've got a backup that you want to keep your power going to your computer, for example, I have one on my computer. It's got a battery in it, so it can power the computer for a while, but it's also got capacitors in there holding a voltage. And as soon as the power goes out, they kick in and help the computer along before the battery can fully kind of engage, if you like. There's a lot of other places, though, you want to store charge like this or store energy. You could also use these to store energy sometimes, but not all the time. You might store energy there if something is true somewhere. You know, if it's raining, I'm going to put a charge on here and store energy, and if it's not raining, I won't. That sounds like a really trite, weird thing, but that's actually how your computer works. Everywhere it's stored information, it's stored it on a capacitor. Charged for yes, uncharged for false. Okay? And all your computer does is work on true, false, true, false, true, false all day long. Okay? And it's all done in capacitors. So that's why we care about capacitors, in addition to the fact that when we hook them up in circuits with some other cool components, we get some really cool circuits that can do some really nice things for us. But we don't know those components yet, so I'm kind of putting that aside for later. All right, I will see everybody on Wednesday.